Okay, hi. So this is chapter 2, section 5, and it's all about imaginary numbers. And complex numbers. Okay, so these are easier than you need to think about them. People make them harder than they need to be, but they're really not terribly difficult. So right now, what I want you to do is grab a calculator, and in your calculator, I want you to try to take the root of negative 36. And what you're going to get is some kind of error, right? So you cannot take the root, the square root of a negative number. As long as it's underneath the root, right? So it has to be square root of a negative number, meaning the square root of something negative underneath the radical sign. And that is because anything underneath the radical is some number times the same number, right? Well, you can't have a negative times a negative under there. That's a positive value, right? So there's no way for you to do that. And here's an example of where you could do something like that. If I had the cube root of negative 8, okay, well, if I break down 8, I get, ignore the negative for a minute, but this gives me 4 and 2, and then the 4 becomes a 2 and a 2. And remember that the index means I need 3 of the same thing to get one out. So a 2 and a 2 and a 2 gives you a 2. Well, what's a negative times a negative times a negative? Well, negative times a negative is a positive, and that positive times this negative is a negative. So you can have a negative underneath a root as long as the index is odd. Then this is okay. But if the index is even, this is not going to fly. Okay? Never ever. So we have to have a way to handle that. And that is actually an imaginary number. So what you have is the square root of negative 1 is equal to the imaginary letter number I. Okay, so if you were to see something like the square root of negative 36, what I want you to think of that as is the root of negative 1 times the root of 36. And whenever you see the root of a negative 1, you're going to let that be I. And then the root of 36 is 6. And so you're always going to write this as the number first and then the I second, and that would be 6I. And it would actually be plus or minus 6I, but we'll get into that later. Okay, but this is the big takeaway here. The big takeaway is if you see a negative underneath a square root, it's an I. And I'm going to say to a million of you during the school year, what's a negative under a root? And everybody's going to say, it's a negative. What? No, it's not. It's an I. Negative under a root is an I. I want you to sear that into your brain. Okay? So here's how something like that is going to work for you. Let me go back to an actual pen. We're going to switch pages. And if you see something like the root of negative 20, okay, I want you to automatically, you see that negative under there, I want you to take that thing and immediately think, just pull it out and rewrite it as I radical 20. Okay, so that negative becomes that I. Okay, and now you take the 20 and you break it down like you always have. So you're going to go rad 4, rad 5. Well, the 4 is a 2. This 2 will go in front of that I. So now this is 2I radical 5. And that's what that answer would be. Okay? So you're going to do some breaking down of things. Oh, let me throw one more thing at you. What if you have negative root of negative 48? Okay, well, the negative under the radical, this one, that one becomes the I, right? So this is now negative I, because that guy becomes the I. This negative is still there. That's that one. Radical 48. And now I'd break down the root of the 48 like I always would. And to me, I do 16 and 3 because that's simple. The 16's a 4. The 4 is going to go between the negative and the I. So this guy is going to go right there. So I have negative 4I radical 3. And that's how that guy would look. Okay? Now, in this section, you're going to have to add, subtract, multiply, and divide imaginary numbers. And adding and subtracting are super simple. Just treat them like a variable. Here's what I mean by that. We'll go to the next page. For me, you're probably still on the same page. All right, so I'm going to go here. And if I had a problem like 4 plus 4i minus 5 plus 3i, just pretend those are x's, right? And you would distribute this, and you could rewrite this as 4 plus 4i minus 5 minus 3i, and then combine like terms. Okay, so when I combine like terms, I'm going to combine my whole numbers. That's going to give me a -1, and then combine my imaginary numbers, and that's going to give me 4 minus 3 is 1, so positive 1i. And this 1 on the I is not necessary, so this would look like -1 plus I. And these, all of these, are complex numbers, which are a real number, and then an imaginary number, where they are written in the form a plus bi, where the real number is the a and the imaginary number is the b, and they should always go in this form: a, the real number first, b, the imaginary number second. Varsity is not super picky all the time, so it'll take the imaginary number first. So it would have taken I minus 1 in this one. Most of the time. Sometimes it'll mark it wrong. So you should just kind of always try to do this when you put your complex numbers in. Okay, so just adding and subtracting, you're just combining like terms. Super straightforward. All right, here's where things get a little bit dicier. So let's go to another screen. And so by definition, remember that I is equal to the root of -1, right? So when you write an answer, to a problem with imaginary or complex numbers, you cannot leave a power on the I. Okay, so you can't leave I squared, I cubed, I fourth, I fifth, I sixth, whatever. You just can't do it. It's not allowed. So we're going to give you some things that you should probably put in your formula journal. All right, so never ever leave this. Always simplify to a single I, okay? So don't leave the square root of -1. Always simplify to I, okay? So that's the first thing you need to know. But then if you see I squared, well, that's equal to I times I. And I times I is equal to the root of -1 times the root of -1. And we know from all of the root stuff that we've done that when you multiply a radical times itself, you end up with just that value. So if you see I squared, you're going to replace that I squared with -1. Okay? Always. Just do that. I explained why, but that's what you're going to do. So if you see I squared, you're going to put in there a -1. Okay? The next rule. If you see an I cubed, that's equal to I squared times I. Well, we know that I squared is equal to a -1 times an I is equal to a -I. Okay, so if you see an I to the third power, you're going to replace it with a -I. Okay, and then the next one is if you see I to the fourth power, well, that's equal to I squared times I squared. And we know that I squared is equal to -1, so that's -1 times -1, and -1 times -1 is +1. So if you see I to the fourth, you're gonna make that a +1. Okay, and then actually what happens, this is kind of wild, it's like a cyclical wheel. I to the fifth is the same as I'll show you. So if you see I to the fifth, that's actually I to the fourth times I, right? And we know I to the fourth is equal to 1 times I, so that equals I. So I to the fifth is the same as I, which is I to the first, right? And then if you see I to the sixth, well, that's I to the fourth times I squared. And we know that I to the fourth is 1, and I squared is -1, and 1 times -1 is just -1. So this is the same as I squared. Excuse me. Or, I'm sorry, I squared is -1. So that is the same. They're the same values. Excuse me. And then you might be able to guess, excuse me, that I to the seventh would be equal to I to the third, which is just -I, right? So it just keeps going around and around and around. So you can kind of figure out what they're going to be. But these are really the only 4 that you need to know. Oh, let me highlight that one at the top. I think we have a purple E highlighter. This guy. Oh, now you can't see him. But those 4 are the ones you need to know. I to the first, I to the second, I to the third, I to the fourth. And that should leave you in good stead. Okay? So, let's go take a look at multiplying. Multiplying complex numbers. So we have to do multiplying and then, excuse me, and then dividing. And if you remember those little rules in there, you'll be just fine. So this is like foiling, right? If we have something like 4 minus 2i, and then 4 plus 3i, I'm having a sneezing fit. I'm really sorry. All right. Well, we're going to FOIL this out. So this is going to give us 16. This is going to give us plus 12i. This is going to give us minus 8i. And this is going to give us a minus 6i squared, right? I times I is I squared. Okay, well, there's another sneeze coming. So we know that I squared is equal to -1. So this is really -6 times -1, which makes this -6 a +6. So what I squared really does is it changes the sign on the number in front of it, and it eliminates the I squared. So now we're going to take these two guys. They're like terms. 16 plus 6 is 22. And these two should be like terms. 12i minus 8i. They can be added together. And we get a plus 4i. And that would be the answer to that foiling problem. Okay, so that's pretty easy. If you can FOIL and remember not to lose track of the I squared, you're good to go. And then if you can multiply, you can also divide because you learned the rules for dividing when you divided radicals. So they're essentially the same. So let's go over those. All right, so we will kind of split this in half. And we are dividing complex numbers. And this has one term in the denominator. And this has two terms in the denominator. We're going to handle this exactly like we did with radical expressions, okay? So, excuse me, if we see something like, let's do a little recall. If we had something like 3 over rad 7, remember that we multiplied by the radical in the denominator. Because we couldn't leave a radical in the denominator, right? That was the point. So we multiplied by rad 7 over rad 7, and we got 3 rad 7 over plain old 7, right? It'd be radical 49. This can't be reduced, so this would be the answer. Well, this is remarkably identical. In these, we, guess what? Can't leave an I in the denominator. And we are going to multiply by I over I. We don't need to multiply by the coefficient because we're just going to make it bigger by a factor of that. So if we see something like 4 over 3i, we're just going to take this guy and we're going to multiply by I over I. Okay, so that's our strategy. And we're going to get 4i over 3i squared. Well, remember that I squared becomes a -1. So this is 3 times -1. So this is now 4i over -3. And that -3 can't go in your denominator. So it can either go in front or up here. So we'd have -4i over 3. Super easy to do. That's all you got to do with that. Okay? Likewise, on this guy up here, we are going to multiply by the conjugate. Okay? Recall that the conjugate was the denominator, is the denominator. With the middle sign changed. Okay, so if our example looks like this, 4 over 3 plus 5i, right? The conjugate is going to look like 3 minus 5i. And we're going to multiply that out. Also remember in the last section, I said to put parentheses around anything with more than one term. So we're going to do that here. We're going to distribute here. So we get 12 minus 20i over, okay, 3 times 3 is 9. We get a minus 15i plus 15i, and then minus 25i squared. Okay, well, these two middle terms are going to cancel each other out, right? That should happen just like it did before. And then here I've got the I squared turning this sign to the opposite. So I've got 9 plus 25 down here, which is what, 34. Okay, so now I've got 12 minus 20i over 34. And if you can simplify, you need to. And sometimes that's just dividing out a common factor. So here I know for sure I can divide out a 2, right? So that would make this a 6 minus a 10i over, well, it's half of 34, 17. And 17 is prime, so I can't go any further. And that would be the expectation, okay? Let me say, or let me show you how, if, this is an if this had been negative, remember that we would be expected to change signs. So now this would be a negative 6, this would be a positive 10, and that 17 on the bottom would become positive, okay? So that's important for you to see how that would happen, all right? That didn't happen. That was a if, all right? But that's pretty much, I think, what you need to know for imaginary numbers and complex numbers. The very last question, number 16, is a little bit outside the box. So if you need to come and ask me how to get that one done, it's actually easier than it appears in varsity. It is one you might want to throw in your formula journal, as are, where were those rules? These rules. You might want to throw these in your formula journal. Okay? I would highly recommend so you don't forget. Also, you know, remember that you should be, whatever page you're on, putting this at the bottom down here. This is 2 dot, what are we on, 5? If that's a left-hand page, or over here, if that's a right-hand page, so you can easily keep track of where you're finding stuff in your notes. Okay? All right, well, that's it. Toodaloo for now.